In this video, we'll be multiplying radical expressions. When multiplying radicals of the same index, and that's important, it has to be the same index, you're going to multiply what's outside the radicals together and leave the product outside the radical. You're going to multiply the radicands together and leave the product inside the radical, and then you're going to simplify the radical. So let's multiply 2 times the cube root of 4 times 5 times the cube root of 12. So we multiply the numbers that are outside the radical and leave it outside. So that's going to be 2 times 5, 10 on the outside. And then you multiply the numbers that are underneath the radical together and put it underneath the radical. So 4 times 12, that's going to give us 48 underneath. Now we want to simplify that cube root. We're looking for the largest perfect cube that's a factor of 48. 8 is going to be our largest. So this ends up being the cube root of 8 times the cube root of 6. Now don't forget to bring down that 10. We're going to have 10 times cube root of 8. That's a perfect. That's just 2 times the cube root of 6. And then we want to multiply those numbers both outside the radical together. 10 times 2, we get 20 times the cube root of 6. Next, let's multiply -3 times the fourth root of 9a squared b to the third times 6 times the fourth root of 9a to the seventh b to the eighth. Now those are indices. That's an index of 4 there. Those are not exponents. So I'm going to multiply the numbers that are outside the radical together and leave it outside. -3 times 6. It's -18. And then we're going to multiply what's underneath the radicals together, and we're going to put it underneath this fourth root. So 9a squared b to the third times 9a to the seventh b to the eighth. Remember, we'll be adding our exponents here. This gives us 81, a to the ninth, b to the 11th underneath. We want to simplify the radical. I like to break it up into the fourth root of the numerical part of the radicand and then the fourth root of the variable part, and simplify those separately. We want to look for the largest perfect fourth that's a factor of 81. But oh wait, 81 is a perfect fourth. This right here just simplifies down to be 3. So we have -18 times 3, and now we'll deal with the variables. 4 goes into 9 2 times, so that's a to the second on the outside. We're going to have a remainder of 1, so that's a to the first underneath. 4 goes into 11 2 times, that's b squared on the outside. We have a remainder of 3, b to the third goes underneath. And now we just want to clean up this outside part. Let's multiply -18 times 3, get -54 a squared b squared times the fourth root of ab to the third. When you first looked at this example, you may have thought, oh, well, I could have simplified the variables under that second radical first. That's true. You could have done that and then multiplied, but then you would have to simplify the radical at the end anyways. So if you end up simplifying first, you actually are creating more work for yourself. because you would simplify, multiply, and then simplify a second time. I recommend to lessen the work, just multiply and simplify one time at the end. Next, let's multiply. We have two binomials here. 11 square root of x plus 4 square root of y times 2 square root of x minus square root of y. Even though these expressions have radicals, it's no different than multiplying any two binomials together. We're going to do repeated distribution. Maybe you like the word FOIL. (11 square root of x times 2 square root of x). We multiply what's outside the radicals together and leave it outside, and then we multiply what's underneath the radicals together and leave it underneath the radical. Then we're going to have 11 square root of x times a negative square root of y. Multiplying our outsides together, 11 times negative 1, that's going to be negative 11 on the outside. X times y, that goes underneath. 4 square root of y times 2 square root of x. Multiplying our outsides together, we're going to get a positive 8. Multiplying what's underneath together, we could either write that y times x or x times y. And then lastly, we have 4 square roots of y times negative square root of y. Multiplying our outsides together, 4 times negative 1, that's negative 4. And then y times y squared underneath. We've multiplied. Now we're ready to simplify any radicals. We have the square root of x squared. And our index is 2. 2 divides into 2 one time, so that's x to the first on the outside with no remainder. You could also think of it as the square and the square root cancel each other out since x is positive. We have a similar thing happening with our last term. We have the square root of y squared. The square root of y squared is just y. I did skip over the radicals in the middle. Here we have an index of 2 and exponents of 1. How many times does 2 go into 1? It doesn't. Anytime the index is greater than the exponent on the variable in the radicand, you can't simplify it. We just have to leave it there. But I would like to point something out to you. Look at these two middle terms here. Notice that they are both the square root of xy. Well, these are called like radicals. Like radicals have the same index and the same radicand. So since they're both the square root of xy, they're like radicals. And like radicals can be combined. All we need to do is add and subtract the numbers in front and bring the radical along. This is similar to having like a negative 11r plus 8r. All we do is add the coefficients, negative 3, and then the variable stays the same, negative 3r. Same thing here. So negative 11 square roots of xy plus 8 square roots of xy gives us negative 3 square roots of xy. And then we have our minus 4y. In our last example, you'll notice that we have a binomial squared. It's a very common mistake that people just want to apply the outer exponent to everything on the inside. You cannot do that here because our operation is subtraction. You can only apply the outer exponent in when the operation inside the parentheses is either multiplication or division. If the operation on the inside is addition or subtraction, you instead need to write it twice and then multiply it out. Two times the square root of x times 2 square root of x, multiplying our outsides together, that's 4. Multiplying our insides together, that's x squared. 2 square root of x times negative 4, negative 8 square root of x, negative 4 times 2 square root of x, negative 8 square root of x, and negative 4 times negative 4, positive 16. We want to simplify any radicals that we can. We have the square root of x squared. That simplifies to just x. Can we simplify the square root of x? No, we cannot because the index is greater than the exponent. We want to look for like terms to combine. We notice that again we have like radicals here in the middle. Negative 8 square roots of x minus 8 square roots of x gives us negative 16 square roots of x. We get a final answer of 4x minus 16 square roots of x plus 16.